Correlation is the connection between two or more variables, so x and y, things like that. So the connection between them. We've already talked about correlation with scatter plots. It can be positive, negative, or no correlation, right? We know this, I hope. Causation, however, is when one variable produces or causes change in the other variable. And when you get to psychology, if you have, especially if you take psychology at Mizzou with Sam Jensen's King's mom, she will say in Yale, correlation does not imply causation. It doesn't cause it. Just because two things move together does not mean that they cause one another. And so let's look at an example and decide if we can figure out whether correlation here does imply causation.
What if the ice cream
Murder rate. Hold off on that. Hold on. Murder rate. So as you see, the murder rate is going up at the same time the ice cream sold is going up. What? Describe the correlation. This is a positive correlation, right?
Mm-hmm.
Does this graph illustrate correlation or causation? Be with me, please. No, it does not illustrate causation. And I hope that when we're looking at something like this on the EOC, we recognize just because these two things have a positive relationship, as one increases, so does the other, just because they have a positive or negative relationship does not mean that the x variable causes the y, or vice versa if we were to switch this around, which we probably should. It's probably caused by an outside influence. It's probably caused by, we said temperature.
They spiked the ice cream with paint, and that's why everyone's dead.
Okay, so we're going to look at two more here. We're going to look at two more. The age of a car and its resale price. So think about if that's correlation. Will it have a positive or negative relationship? So yeah, as the age of the car typically goes up, the resale price usually goes down, right? So yes, it does have correlation. And you guys said negative because as one go up, the others goes down. But let's think about whether, does the age of a car directly and always cause the resale price to go down? Can someone raise your hand and tell me what's a situation when that is not the case? Finn?
What about a car that's like historic from like the 1900s?
Right. Or what if you total your 2018 car? Will it have a pretty good resale price? No. So no, this is not causation. Just because it has a relationship does not mean that one causes the other. Okay, next one. The points a student earns in class in their final grade.
Definitely correlation.
For sure, correlation. What kind of correlation, guys?
Positive.
Positive? Is it causation?
Yeah.
Can you count on a student's points in class to determine their grade?
Yeah.
Yes, that is causation. You got? Please follow along. We'll go through this quick. You got the least value over here. You have the most value or the greatest value over there. And then it's split up into quartiles. And each of those quartiles has the same amount of numbers in each. This middle line in the middle of the box is the median. It is not the mean. It's not the average. It's the middle number. Okay? So most of the questions that you'll see on the EOC hopefully will just be about interpreting box and whisker plots. So we're going to talk about kind of how it's created. So the first thing that we do is we order the data from least to greatest. So can you go ahead and do that? There should be 24. I'm going to go ahead and start writing the numbers up. If you want to just copy them down for me, I do not care. Okay? Okay, so we got 0, 1, 3, 3. I hope you're writing down the data. Here we go. We're ordering it. You're either doing it with me or you're doing it on your own. 5, 6, 8. So I'm just taking that data in the box and I'm just putting it in the correct order. 10, 10, 12, 13, 13, hopefully I don't miss one. 14, 16, 18, 19, 23, 24, 32, and 45. Here is what we do. If you would read it with me. So after we order the data from least to greatest, how many items do we have total? 24. So cut that in half. 12, cut in half again. Okay, so we should have 6 numbers in each quartile. So I can draw like a line here. There's the first, 1, 2, 3, 4, 5, 6. Second, third, and then fourth quartile. The minimum number? What is the number? Okay, well, let's go to the median first. What's my median? 10, because it's between 10 and 10, which is obviously 10. So it doesn't have a direct median, and so you take the number in the middle. Obviously, it's 10. The max number? 45? Okay, to get Q1 and Q2, which is like the median of the first half, you want the number that's between 3 and 5, which you take the average of. 3 plus 5 divided by 2, what would it be? 4. And then the number that's in between 16 and 17? Yeah, that's what I meant. 16 and 18? 17. Okay, so you're just taking the average. This box plot shows that the middle half of the data with the median cutting a line in between. So it shows the middle half. It also shows the first and last parts with the minimum and maximum numbers. And here's the part that's kind of tricky. So the right side, if you notice, so this is the actual graph that you see right above there. The right side is more stretched out, right? So those numbers have a wider spread. So we're going from 10 to 45 versus 0 to 10. That's a much wider spread. And the mean, the average would be on that side.